I think it's time for another multimeter review. What do you guys think? Hey, what's happening, guys? Today we are going to take a look at another Zotek multimeter. In this case, it is the Zotek ZT-M0, which is a smart and manual multimeter. Kind of a unique animal. You can select your individual ranges, or you can put it in the auto range and let it figure it out for itself, right? Okay. So, in the package, we have the multimeter, and we have the leads, and I think it also came with, a thermocouple. Couldn't get my brain to get those words out. All right. So let's start with my AliExpress calibration standard. And I have marked on here what the readings from my Fluke meter are. And we'll use the same leads we used with the Fluke. And the reason for that is to eliminate any resistance or stray capacitance that exist in the leads. So we'll start with resistance, 179.5K. So we're going to have to go to 600 kiloohms. 179.5, reading 180, close enough, right? Absolutely. Now, let's put it in auto mode and see what it thinks there. Yeah. Read it just fine. Slightly higher in auto mode, but no problem at all. Now let's go over to the capacitance. Let's make sure, yeah, reads capacitance, right? Microamps, milliamps, temp, hertz. Oh, I do not see capacitance. But I could be missing it. So here's what we'll do. We'll put it in capacitance. Mark over here in this capacitor. We'll put it in auto and see what it thinks. Oh, there we go, capacitor. 60.52. Again, we read 59.77. But in auto, yeah, it's not reading the capacitance in auto. And that's fine. Not a problem there at all. Let's take a look at some more capacitance measurements here. Okay, this first one should read about 104. I'm sorry, 10.4. Reading 10.1, yeah, close enough for government work. Next one should be 1.07, 1.079, and 2.77. Thinking about it. Oh, I'm sorry. That is marked 12.77 microfarads. And they are showing me 12.64 microfarads, or in this case, they're showing me millifarads. Very interesting. But anyway, yeah, it's reading them no trouble at all. Let's try a couple bigger capacitor values. And for that, I'm going to switch to the ProbeMaster gold-plated leads. And we will start with 10,000 microfarad. First thing we want to do is make sure we short that out real good. Okay, we'll put that in capacitor mode. $10,000 microfarad. Thinking. We're getting 11.23 millifarad, so a little high reading, but hey, not a worry. Okay, this one is 100 microfarad. Get her on there. $100 microfarad. Come on, baby. Read. $115, yeah. Reading just fine. Not a problem. Let's take a look at a couple more resistance measurements. We'll go with some low to high. Here is a 10 ohm. Well, we got to put it in resistance, don't we, there? 10 ohm. We're getting 10.1. Let's go even lower. Here's a 2.25 ohm. We're getting 2, and the readings are almost instantaneous, which is awesome. Put it in auto mode. Okay, in auto mode, it's reading continuity on that low value. Now here it's showing us the 10. Here's it's supposed to be 10K. Yep, we're getting 10.1. This is 985.6, 986, 987, great. 996.5K. Or 1 mega ohm, and that's close enough. How about 40 megs? Good deal. This is 10.2 megs. No worries at all. And let's check our continuity mode. Pretty quick. I mean, it's not as great as some other ones I've used, but it's still pretty quick. Now, this is also our diode mode. So let's see, how do we switch it into diode mode? Can we just check a diode? Is it automatic? I think it is. Here is a standard silicon diode. Now it's still in voltage mode. How do we do this? Yes, no. Well, it says it's in diode mode. Yep. I am confused. Are we plugged in the right place? Yes. Oh, well, we're backwards. Try it again. There we go. Standard silicon junction diode, 0.616. This is a Schottky, should be around 0.2 to 0.3. There we go. Now our LEDs, starting from the red, which has the lowest forward voltage, around 1.8. It lights it, we get 1.8. Then we have the yellow, should be around 1.9. It is 1.89. Then the white should be around 2.5 volts, 2.6. And the green, 2.3. I got them in the wrong order, don't I? And the blue, yeah, lights them all. They all work out just fine. That is absolutely fantastic. No problems there. Quick look at the battery test mode. Put it in 9 volt. We have a 9 volt battery here. What it's going to do is put a small load on the battery. This one could be dead. Alright, let's just put it in voltage mode and see if we read any voltage. Yeah, that one's pretty dead. That's why that ain't working. I don't think I have any other 9-volt batteries around. Alright, let's get set up and check the current. Yeah, darken things up a little bit here so we can get a chance to see the light. And we have our current output here. We're seeing about 190 microamps. I'll put this in the microamp mode. Sorry, 18 microamps. Alright, let's take this up to 60 milliamps. And we'll dial this up. 1.26, 1.28, 3.02, 2.99. I mean, it's definitely close enough. It's nothing to worry about. 4.1, 6.08. Close. Getting a little further away as we move up. 8.53, 8.43. We're about 100 microamps off. 100 microamps off is not going to mean a thing to you. We're not working for NASA here. 11.0, 11.06, 10.0. Now we're a milliamp off. Now that is unfortunate. 13.85. Okay, now we're 2 milliamps off. Oh. Let's just crank this all the way up to our 20 milliamp range. Perhaps it's not getting enough current. There we go. 20 is right on at 20. Let's take this back down. 16.6, 16.6. That may have been my fault earlier. 13.96, 13.8. Yeah. I wasn't giving the output device enough current. That was my problem. 11.66. So yeah, we're right on. No worries at all. So now let's take it apart. First, we'll see what kind of batteries it uses. AA batteries. Nice. I like AA batteries over 9-volt batteries. They have a larger energy density. So that's pretty nice. Now, got a nice, soft condom on here. Hopefully it won't be too hard to get off. I don't think it will. Some of the harder ones, I mean, you've really got to dig in to get them out. This is not a problem at all. Take the screws out. You can see also it has a LED light on the back. That is a standard feature these days of the cheap Chinese meters. Kind of taken the place of the transistor tester on the cheap meters anymore. Wow. So there's not much going on here. We of course have our chip on board covered under some potting. Got an 8 megahertz crystal here. There is our LED. Made for the British market. It says torch. Zoom on in here. Okay, stop vibrating, camera. Then we've got our beeper. We have a large MELF resistor, which was hand soldered because you can see the flux residue there. This is probably our voltage standard. This is interesting. It says red-green. Alright, we have a little bit of protection here too. I think that's probably a thermistor, marked R10. We have some more MELF resistors. We got a little bit of diode protection going on here. We have our two fuses. This is a 20 amp 250 volt, 600 milliamp 250 volt. And then you can see our current shunt right here. And if you look down in here, you can see they have tinned this track here for more current carrying ability. Yep, this is just about as simple as you can get. There's not much more you could take off of this and still have a working meter, and it is a working meter. The case seems nice and sturdy, and it has a decent lip. That's about 1/4 of an inch. No, yeah, maybe 3/8. Yeah, somewhere in there. 3/16 is more like it. So all in all, decent constructions, you know, on standard with what you're going to find from the cheapo Chinese meters. I did a video about a month ago, it's all linked down below, which is a comparison between a Fluke and one of these meters. You know, if you're interested in what the differences are, check the link. You can watch that video and see, you know, why a Fluke costs $300 and one of these meters it does not. I mean, of course, some of it has to do with the components. But more of it has to do with the way it's constructed for your protection, the build quality, you know, things like that. Plus, it is the name Fluke. You know, if you're working in a professional job with a Fluke multimeter and something bad happens, and you have, say you have to turn in a workers' comp claim and you end up going to court, you are going to be much better off telling the judge that you're using a Fluke meter than you cheaped out and bought a $20 Zotek meter. There's nothing wrong with this meter at home. Nothing. But if you're an electrician and you're making your living this way, then you want to have the professional tools and a company with the reputation to stand behind you if there's a problem. So, all right, it has an doesn't it have an NCV, non-contact voltage? Yes. So if we go auto here, we go NCV, and we bring it up here towards our LED lights. That works out quite well. Quite well indeed. Alright, what else do we have left to test? Let's test the temperature. Okay, temperature. Celsius. Fahrenheit. It's about 69 degrees in here, so that's coming up a little low, which is odd. Alright. So here's some ice water, which should come in, you know, 35 to 40 some degrees. Yeah, that's looking pretty good. Now let's switch that, take that out, and I'm going to grab it in my hand, and it should take me up to about, what, 98 degrees or so. Might not be exact. Make sure we're getting there. 81, 82. 84. Might take a while, you know. We'll pause. Alright, seems to be almost completely stopped here at 86, 87 degrees. But then that's probably, you know, just a skin resistance thing. You know, we're not having a perfect connection. I'm going to put this back into the ice water, and then I'm going to go retrieve the water that I have boiling from the microwave. Okay, that was boiling a few seconds ago. Drop that bad boy in there. See how fast it gets over 200 degrees. It's getting up there pretty quick. Now, I don't expect it to reach 212 degrees because the boiling has stopped and boiling water cools rapidly. It's an interesting thing. If you look here, you can see a condensation on the probe. Come on, you got to get over 200 degrees for me. Come on. You can do it. Or not. I guess it's cooling too rapidly. But yeah, you can see the condensation on there. Pretty cool. So that is going to about cover it for this Zotek meter. They can be found from the usual Chinese suppliers for around $20 US. Hope you guys enjoyed this video. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to you for watching. Watching the videos, liking, and commenting is just as important to me as the monetary contributions I receive from patrons, because it lets YouTube know that you guys are watching this, and I appreciate it. Thank you. That's it. I'm out. Peace. Thank you for all your support, everyone. 2020, I'm hoping, is going to be a great year for us. Everyone who's supported through Patreon and through PayPal donations is fantastic. Everybody who's bought something from the Amazon store, that's what keeps this channel going. I couldn't do it without you guys. You are a part of the team. Hey, feel free to email me, arduino0169@gmail.com. I try and get back to just about everybody.